So I'm going to talk about a particular technology that's from the Netherlands largely, and I would love to be able to talk about lots of things happening in the UK, but there aren't many. It's a little bit of a... We had a discussion, we had a buildings forum at Macdonald only a month or so ago and discussed whether or not we would actually continue to pursue the idea of working in heat network areas. We will, because it's clear that it's going to happen sometime and has to happen sometime, but I have to say we think we're going to concentrate in other countries for the time being to keep our technical skills up, but I can't see a lot of it going on immediately here. So, urban heat sharing. So, I want to talk about what I describe as secondary heat. I don't quite know whether anybody else does, but I mean the waste heat from buildings, which in this case you could consider to be cooling, or any reason for getting rid of heat from a building. And one of the things that's fairly obvious is when you actually look at the way that individual buildings perform, you might be better off looking at groups of them, just from a simple technology aspect. And you notice that some buildings in a city are in need of cooling at the same time as other buildings are actually not in need of cooling. So it varies. But on an immediate, simultaneous basis, that isn't terribly useful. So what we've been looking at, and for the past, getting on for 10 years, trying to promote, is a more seasonal approach to that. Looking at how you might throw heat away, as in cooling a building, but then throw it away in winter, rather than in summer when it's the hardest time to cool a building. You might try and throw that heat away, keep it, and then throw it away in winter. So that's by introducing underground thermal energy storage in one way or another, which then enables you to look at the way that buildings balance their heat loads over the year. And some of them have a significant cooling priority, and others have significant heating priority. What we really want to look at is possible ways of making use of that beneficially, so that buildings effectively become a solar collector, which you can then use for heating the building later on. I'll stop pressing this so hard. So there are other buildings which just seem to create heat, and the data centre is an obvious one, where I've been trying to understand. I can't really get my head around what the electrical efficiency of a data center is, because it basically takes electricity, turns it into loads of data, and everything turns into heat. So to me, it's an excellent thing to put in a place where we need a lot of heat. At the moment, people are putting them in places where it's easy to get rid of the heat, so building them in cold climates. Potentially, I think you should be building them in the suburbs, potentially, that's where heat is required. Perhaps it's a way of making use of it. So this is a Telecity group in the Netherlands, and they're using aquifer thermal energy storage for a 9 megawatt capacity data center. So what is underground thermal energy storage? As I try to explain, it's the idea that when you cool a building, you're throwing heat away from that building. And rather than try and heat the atmosphere up outside, you just put it into the ground. And there's several ways of doing it: boreholes or wells. And if you're talking about large scale, then the more efficient is a well, basically. So take water out of a well, use that for cooling, warm that water up, put it back down into a borehole. The same borehole at higher level, or a different borehole farther away. So that makes the efficiency of the heat pump, which is the way you're going to have to raise the temperature of the water in the heating season, greater. Because currently the problem is that we're trying to heat buildings with heat pumps which don't work as efficiently as they should do in the coldest season. So if you can possibly give them a bit of a raised temperature, they will work more efficiently. And there are obviously other ways of doing that. But One way of doing it is to provide them with a warmer starting point and a more consistent temperature from the ground. And this is a diagram that simply shows that. It shows cooling off this building, taking water out at about 7, raises the temperature, pop it back into the aquifer, and then reverse the process and use a heat pump to heat the building and put the water back into the well, which is then cool water, so you create a warm well and a cool well. And if you do that, and then you plan it across the whole city, and I think you can do that and plan it across a whole city, because part of what actually happens is when you put the water into a well, you have very large volumes of warm mud, shall we say, for the sake of argument, rock, whatever you like to call it, at about sort of down 80, 100 metres deep, large volumes, which move around subject to water flow through the aquifer itself. And that means that you don't necessarily have to actually directly connect all the networks up, and potentially it might provide you with the possibility of doing one here but not having to cross a very major road, but still using heat from the buildings across the way. And old buildings need a lot of heat, and new buildings generally don't. So is it feasible across the UK? Well, this is a technology, as I said, is very much developed fast in the Netherlands. When it's developed in the Netherlands for a simple reason, they have a very straightforward aquifer arrangement in the Netherlands, and here we don't, because we were right at the end of the Ice Age and all the rubbish ended up piled up in our country or worn away. So it's quite complex, our geology, hydrogeology, but that's where it's a matter of building engineers like I am working with hydrogeologists, which is the benefit of me working in Mott Macdonald these days. Is I started as a building engineer and now I can work with a hydrogeologist, and it makes life a lot simpler. But this is a map of looking at the aquifer thermal energy storage possibilities in the UK. And the red area, for a change, is the good bit. So the red areas and the more orange areas are the places where it might possibly be useful. And if you start to then map on the cities, you discover that quite often the cities fit in those areas. So it's not as it's not as bad as it looks. When you think initially, oh my goodness, it's all green, it can't possibly work, when you actually map the cities on, you find it's actually, they are in the right places. And one of the reasons for thinking about this is the temperatures of the water we're talking about storing and the temperatures of the water we're talking about distributing are not hot. They are ambient temperature. So 7 to 20 degrees, that sort of temperature. And that means that the pipework you can distribute doesn't have to be highly insulated. It's plastic, MDPE, that's the same plastic that's used in normal water mains distribution. It's relatively low cost pipework. Obviously you still have to dig the roads up, which is a slight snag, I admit, but I think we're going to have to dig all our roads up sooner or later. And looking at Eindhoven University is a demonstration place where there's a 20 megawatt thermal load. It's not fully balanced, but it's an existing campus of some 20,000 students, and they've been adding to their network over time, which I think is a key requirement for any urban heat sharing network, is that we can gradually add things into this. So just looking at the London hydrogeology, we're talking about drilling down through the London clay deep into the chalk. In London, it's chalk aquifer. Sadly, chalk aquifers are not the world's greatest things to predict. So one of the snags with this approach is that you have to do both a desktop study, and then before you can actually do this, you're going to have to drill a well if somebody hasn't already drilled one for you. So you're talking about probably £20,000 expenditure after your desktop study to know whether or not this will work. So that puts a sort of a immediate barrier to doing it. But it often does work, and there's quite a lot of wells already drilled across London, so you can be fairly sure whether it's going to work or not, but not absolutely, because it's all about fissures in the chalk. In places where there's sandstone, so where's a sandstone? Nottingham, for instance, is a sandstone aquifer. It's much more consistent, and you know what's going on. So if you look around the cities, maybe those are the ones maybe where one would actually begin. And this is because we have a serious problem with our existing stock. That's where we have a problem with heat. Those are the things that need heat. We're rapidly moving to the point where we're being required to design zero carbon buildings. So it's only, 3 years away before we start having to produce zero carbon buildings. I think that's a big ambition in my view, but there we go. I'm sure we'll manage it somehow. But it doesn't get us past the fact that most of our buildings are already there. And they are the ones we're going to have to deal with, and they're the ones we live in, and they're the ones we work in. So it's going to be pretty disruptive if we have to physically change those buildings, and perhaps we don't want to overclad all of them, although that's quite a nice art piece. So in Amsterdam, they've been investigating how they might plan this whole process. And they've done something like 1,000 now across the Netherlands. And the water authorities have actually become involved. So it's not just the energy producers, the traditional energy producers who are now selling energy, but Brabant Water, for instance, is selling heat and cooling. Indeed, perhaps you should think of this initially as cooling, because that is the cheapest and the most efficient thing you can get out of this, is cooling. So cooling just uses water directly from the aquifer straight into your normal, through a heat exchanger, to provide cooling. Now cooling has traditionally been thought of in the green world as a really bad thing. Actually, if we start to look for heat balance, cooling becomes a good thing. So in cities, maybe that's what we should be thinking about. But you need to plan, and who owns the heat, and how it's controlled underneath the ground. Well, the Dutch are on their way to agreeing the laws that enable that to happen. It's not really developed here, because at the moment we have fairly few of them. But if you have an entire city, and you look at these big blobs of heat, we're talking 50, 100 metre diameter spaces below ground. It may be warm, may be hot. Somebody has to plan that all out. At the moment, one of the things that we've been working on is the 1851 Commission, and that is Imperial College, Royal Albert Hall, Natural History Museum, the V&A and the Science Museum, and they all were part of an area that was built in 1851 for the Great Exhibition. So a study was done about the possibility of linking them all up, which came out with some very positive results, suggesting if you linked in with CHP and aquifer thermal energy storage, you would potentially save 30% of the carbon that they're currently doing. At the moment, the current situation is that each of them are individually looking at that possibility, and I think Imperial College are probably the key one at the moment. So it's looking at using individual buildings of different types to provide you with heating and cooling. Enables you to phase it. It's going to have to be planned. And our big issue is actually space heating in our existing domestic stock, because we've got such rubbish existing domestic stock. And that, I think, is where we have a problem that we need to work out. And I don't quite know the answer, but there's people in the audience who've suggested it. And I think the water mains may be part of it. So this is just showing the breakdown of non-domestic energy consumption. and then again how non-domestic heating and cooling break down into processes. So in the Netherlands, this has actually been growing quite steadily now, and this is just looking back since over the last decade really, and it's grown since 2008. This is starting to seriously take off. And in the UK, we have a few samples, and one of the interesting things that's happened is that high-end housing has become quite a popular way of doing it, and that's really because of our planning laws rather than anything else, because you've got people who would like, you've got highly insulated housing, which would be nice if it had cooling, doesn't need a lot of heating, it naturally has a reasonably good balance, which means that the storage system would be good. So curiously enough, high-end housing has turned out to be a place where this sort of technology is starting to be used. And this is Wandsworth Riverside. And IFTech is the Dutch companies and the UK version of it that is developing it. We have put in a few, and the latest one we put in is at the Maritime Museum in Greenwich. And I think it's the first refurbishment project to use it. And that's it. I think I would love to see this happen more, but we haven't really talked about networks, and that's because I haven't seen any begin. Thank you.